If two or more vectors are said to be collinear if they are parallel to the same line, then they are called as collinear vector. A very important definition, you may expect this for 1 mark. Cos theta is equal to the angle of intersection between the vectors. Cos theta is equal to vector A dot B divided by length of A into length of B. This is the form. These two vectors will represent the adjacent sides of a triangle. Then the area of a triangle, area of triangle is equal to half into length of A class B. Hello dear students, welcome to this session of mathematics revision class. I am Mr. Niranjan, faculty department of mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to discuss regarding very important and simple chapter, that is vectors. Now let us know what is the weightage for this chapter. So in this you will get 1 mark 2 questions, 2 marks 2 questions and 3 marks 2 questions. Totally you will get 12 or 11 marks from this chapter. Now let us recall all the definitions and types of vectors. Now a quantity having both magnitude and direction is called a vector quantity. A quantity having both magnitude and direction is called a vector quantity. Example for vector quantities are velocity, force, acceleration, etc. They are all vector quantities. So having both magnitude as well as the direction. And the opposite of a vector quantity is a scalar quantity. Scalar quantity means a quantity having only magnitude but not direction. It will have only the length but not direction. So that is a quantity having only magnitude but not direction is called a scalar quantity, means having only magnitude but not direction. For example, 10 grams or 10 centimeters. Here they are all nothing but scalar quantity having only a particular mass but not particular direction. Now a vector is represented by a direct line segment AB. The arrow mark indicates the vector from A to B. A to B, this is vector from A to B. The arrow mark indicates the vector is from A to B, denoted as small a. So A, the arrow mark indicates the direction of the vector from A to B. So A is called the initial vector, initial position, and B is called the terminal position of the vector. And the length of the vector AB is denoted as magnitude of this AB, or length of AB is called as the length of the vector or magnitude of the vector AB. Now, so a quantity having only magnitude but no direction is called a scalar quantity. Example for scalar quantity are length, mass, time, etc. or example for scalar quantities. Now the very important concept you might have been studied is the position vector of a point. Suppose if P, X, Y, Z be any point on the space, then OP is called the position vector of the point P with respect to the origin O 0, 0, 0. Therefore, the position vector of this OP with respect to the origin X, Y, Z is denoted as vector R is equal to vector R. OP is equal to Xi plus Yj plus Zk along with the unit vectors. Vector OP is equal to Xi plus Yj plus Zk, Ijk are the unit vector. And the magnitude of this vector OP or vector R is given by square root of x square plus y square plus z square. Root of x square plus y square z square will give the magnitude of the given vector. Now, see, this is the position vector. Let P, X, Y, Z be any point. So, the position vector of P is nothing but vector OR is equal to I cap, J cap and K cap are the unit vectors along the x axis, y axis and the z axis. Therefore, the position vector with respect to the origin are denoted as vector A, B, C, as OA is equal to vector A, OB is equal to vector B and OC is equal to vector C. So, these are vector OA, OB and OC. OA is equal to vector A, OB is equal to vector B and OC is equal to vector C. So, therefore, the combined equation vector, these are the position vectors of A, B, C with respect to the origin. Now, move on to the next types of vectors. Now, in types of vectors, so you may expect one more question from this. Zero vector. A vector whose initial and terminal points coincides is called as a zero vector. That means a vector whose magnitude is 0 is called a zero vector. A vector whose initial and terminal points coincides is called as a zero vector or a null vector, denoted as 0. A to A, B to B, that is the initial and terminal points will coincide. whose magnitude is 0. Unit vector means a vector whose magnitude is unity 1, a vector having unit magnitude. A vector whose magnitude is 1 or unity is called a unit vector, denoted as a cap, right? Now, co-initial vectors means two or more vectors having the same initial point are called as the co-initial vectors. So, your vector OA, OB, OBC are called as the co-initial vectors. So, two or more vectors having the same initial point are called as co-initial vectors. Vector OA, OB, OC are called as the co-initial vectors, right? Now, move on to the next one, collinear vectors. Collinear vectors means two or more vectors are said to be collinear if they are parallel to the same line. If two or more vectors are said to be collinear if they are parallel to the same line, then they are called as collinear vector. Very important definition, you may expect this for 1 mark. Now, equal vectors. Equal vector means two vectors are said to be equal if and only if they have the same magnitude and the direction, denoted as vector A is equal to vector B. If two vectors having same magnitude and same direction, then they are said to be equal vectors. Okay. Now, next, negative of a vector. This is also very important. Negative of a vector means a vector whose magnitude is same as that of the given vector, but the direction is opposite to that of the given vector. So, a vector whose magnitude is same as that of the given vector, but the direction is opposite to that of its given vector is called as the negative of the vector, denoted as minus AB. That is, the negative of vector AB is BA, that is denoted as vector BA is equal to minus of AB. So, if this is the vector A to B, then the negative of vector is nothing but B to A, that is BA is equal to minus of AB. Suppose if A is the vector, then the negative of this is denoted as minus A vector, right? Important. Now, move on to the next one, unit vector. Unit vector along A. So, unit vector means a vector whose magnitude is 1 is called a unit vector. So, unit vector along the vector A. Suppose if this is the vector A and the unit vector A cap is given by vector A cap is equal to vector A divided by its own length. So, unit vector along vector A is A cap is equal to vector A divided by the length of the given vector. This is called the length of the given vector. Okay. Now move on to the next concept, components of vector and the position vector. If OA, OB, OC is equal to 1 unit vectors, if OA length of OB, length of OC is equal to 1, having 1 as unit vector of magnitude 1 along OX, OY and OZ are denoted by vector I cap, J cap and K cap of the point P, X, Y, Z. So, then this is the position vector of the point P. The position vector of the point P is denoted as vector OP or vector R is equal to Xi, that is X into I cap plus J into Y cap plus Z into K cap. Xi, that is Xi cap plus Yj cap plus Zk cap. This is called the position vector of the point P, X, Y, Z, and it is denoted as OP is equal to vector R is Xi plus Yj. And what is the magnitude of this? The length of this vector is square root of X square plus Y square plus Z square. That's it. Okay. Now, see, the position vector of P, X comma Y is OP is equal to Xi plus Yj. Therefore, the length of OP, very important, magnitude of OP is mod Xi plus Yj square root of X square plus Y square. So, the position vector of P, X comma Y comma Z, P, X, Y, Z. If there are 3 points, P, X, Y, Z is vector OP is equal to Xi plus Yj plus Zk, and the magnitude of this vector OP is equal to X square plus Y square plus Z square under root. Now, suppose if A and B are any two vectors, then vector A is equal to A1i, A2j, A3k, vector B is equal to B1i, B2j and B3k. Then how to add? The addition of vectors can be done by adding the corresponding coefficients of I, J and k. A plus B can be written as adding the corresponding coefficients of I, J and k in both the vectors. So, coefficient of I in vector 1 and 2 is A1 plus B1 into I, J is A2 plus B2 into J, A3 plus B3 into K. Similarly, the subtraction of vector is the difference A minus B is equal to sum or difference. A minus B is A1 minus B1i, A2 minus B2j plus A3 minus B3k. Now, suppose if K into A plus B, if k is any constant, k into vector a plus b is also equal to k into vector a plus k into vector b. K in times m into vector a is equal to, just multiply, m is also a constant, k into m into vector a. Suppose if a and b are two vectors, if these two vectors a and b are said to be collinear, then we are going to verify that vector b is equal to lambda times vector a. So, to verify whether the given vectors are collinear, just verify that the vector b is equal to lambda times vector a, or so a1 by a2 is equal to b1 by b2 is equal to c1 by c2 is equal to lambda. Now, move on to the next. Now, based on this, let us discuss the problems. Now, very important for 1 marks, 2 marks and 3 marks. So, I will discuss only very important problems in each type, 1 mark question, 2 marks questions and 3 marks questions. Now, find the unit vector in the direction of vector a. So, you know the unit vector is a cap is equal to vector a divided by its own length. Now, what is vector a here? 2i plus 3j plus vector k cap divided by its own length. Length of I coefficient of I is 2, 2 square is 4 plus 3 square is 9 plus 1 square is 1, that is 2i plus 3j plus k divided by 9 plus 1 is 10 plus 4 is 14. So, you can write 2 by root 14i plus 3 by root 14j plus 1 by root 14k cap. So, these are the unit vectors. So, this is the unit vector n cap or a cap. So, the unit vector along A is vector A divided by its own length. That's it. Now, so I will write this properly. 2 divided by root 14 into I plus 3 by root 14 into j plus 1 divided by root 14 into k cap. Now, move on to the next one. So, find the unit vector in the direction of vector A I minus 2j that has a magnitude of 7 units. So, therefore, the required vector is equal to 7 times the unit vector, 7 times the unit vector, that is nothing but a cap. So, find out what is a cap. Vector a cap is equal to vector a divided by its own length, that is vector a is I minus 2j divided by unit vector. So, square the magnitude of this 1 square is 1 plus 2 square is 4, I minus 2j divided by root 5. Simplify. So, the required vector is equal to 7 times vector I minus 2j divided by root 5. So, that's it. This is the required vector. Okay. Now, move on to the next problem. Next one is, so this is very important theorem actually. This is very important derivation. You may expect this for 3 marks. So, you might have been studied regarding internal and external division. Show that the position vector of the point P divides the line joining AB, that is having the vectors vector A and vector B as position vectors internally in the ratio m is to n is vector R is equal to m into vector B plus n into vector A divided by m plus n. Very important. So, what is to prove is to prove that vector R is equal to m into vector B plus n into vector A divided by m plus n. Now, let us consider let O is the, let A and B are any 2 points whose position vectors. So, position vector of A is vector OA is equal to vector A, OA is equal to vector A, and the position vector of B is vector OB is equal to vector B. Let P be any point on the line AB. This P divides AB in the ratio m is to n. Suppose if P divides AB in the ratio m is to n, then the position vector of P is given by vector OP is equal to vector R, right. This is the construction part. See here, that is let A and B are any 2 given points with position vector OA is equal to A and vector OB is equal to vector P. Let P be any point which divides AB internally in the ratio m is to n. So, since P divides AB internally in the ratio m is to n, therefore, we can write PB divided by AP. So, P to B, this distance divided by this distance, PB divided by AP is equal to n by m. Now, just cross multiply. If you cross multiply, what you will get? M into vector PB is equal to n into vector AP. M into what is PB vector? That is nothing but vector OB minus vector OP is equal to n into vector OP minus vector OA. Now this is M into what is vector OB and OP? OB is equal to B and OP is equal to R. Vector B minus vector R is equal to n into, again OP is R and OA is equal to A vector, R minus vector A. That's it. So this is very important concept. Since P divides AB internally in the ratio M is to N, therefore PB divided by AP is equal to N by M, cross multiply. M into PB is equal to N into AP. M into PB is OB minus OP is equal to N into vector AP is nothing but OP minus OA, second vector minus first vector. M into OB, you know, vector B, and OP is position vector, that is R. N into OP is equal to vector R, and OA is nothing but vector A. Multiply it, that's it. M into vector B minus M into vector R is equal to N into vector R minus N into vector A. Just equate the terms which contains R on one side. So this M into vector B as it is, transfer minus becomes plus N into vector A is equal to N into vector R plus M into vector R. So you can write M into vector B plus N into vector A is equal to R is a common factor, we can write M plus N. So therefore vector R is equal to M into vector B plus N into vector A divided by M plus N, which is the required answer. So vector R is equal to M into vector B plus N into vector A divided by M plus N. That is nothing but your internal division. This is the required answer. Hope you followed. Very important. You may expect this theorem for your final examination 2023. Sure question. Now, based on this, let us take an example. Find the position vector of a point R which divides a line joining P and Q internally and externally in the ratio 2:1, where A and B are given. Now, what is given? Given M is to N is equal to 2:1. Therefore, M is equal to 2, N is equal to 1. Vector A I plus 2j minus k cap. Vector B is equal to minus I plus j plus k cap. Let us take first internal division. Internally, vector R is equal to M into vector B plus N into vector A divided by M plus N. What is M? M is equal to 2 into vector B is minus I plus j plus k plus 1 into vector A I plus 2j minus k, vector I plus 2j minus k divided by M plus N. What is M plus N? 1 plus 2. So therefore this can be written as vector R is equal to multiplied minus 2I plus 2j plus 2k, again plus I plus 2j minus k divided by 3. So vector R is equal to minus 2I plus I is minus I, 2j plus 2j is 4j, and 2k minus k is plus k divided by 3. This is the internal division. Now to find external division, so externally, second one. Externally, vector R is equal to M into vector B minus N into vector A divided by M minus N. That's it. What is M? M is 2 into minus I plus j plus k minus N is 1 into I plus 2j minus k divided by M minus N. 2 minus 1 multiplied minus 2I plus j plus k, multiply by negative sign minus I minus 2j minus into minus plus k divided by 2 minus 1 is 1. So therefore vector R is equal to minus 2I minus I is minus 3I plus j minus 2j is minus j plus k is plus 2k divided by 1. So that is nothing but vector R is equal to minus 3I minus j plus to k cap is the external division. So, internal and external division. So, you may expect one question from this either for derivation or for problem. Now, let us move on to the next concept. Next concepts are scalar product and dot product. Scalar product, or it is also called as dot product, then vector products, then box product of or scalar triple product. So, let us know regarding first scalar product or dot product of two vectors. Suppose if vector A is equal to A1i plus A2j plus A3k and B is equal to B1i plus B2j plus B3k are any two vectors, then the dot product of these two is denoted as A dot B is equal to, just multiply the coefficients of I, j and k in both the vectors. Coefficient of I is A1, here it is B1. Coefficient of j is A2, B2. K is A3, B3. A1, B1 plus A2, B2 plus A3, B3. That is nothing but A dot B is equal to A1, B1 plus A2, B2 plus A3, B3. If you multiply, you are going to get a scalar quantity. Now, you know A dot B, the dot product is always equal to A dot B is equal to length of A into length of B times cos theta, where cos theta can also be written as vector A dot B divided by length of A into length. So, to find the angle of intersection between the two vectors, we are going to make use of the formula cos theta is equal to the angle of intersection between the vectors. Cos theta is equal to vector A dot B divided by length of A into length of B. This is the formula. Suppose if A dot B is equal to 0 means, then the vector A is perpendicular to vector B. If A dot B is equal to 0 means vector A and vector B are perpendicular to each other. Now, by knowing this, let us know the projection. Suppose if A and B are any two vectors, A and B are any two vectors, the projection of A on vector B or B on vector A. The projection of vector A on B is given by vector A dot B divided by the length of vector B. The projection of vector A on B is equal to vector A dot B divided by length of B. Similarly, the projection of vector B on A is A dot B divided by length of the vector. So, projection of A on B is nothing but depends on the length of vector B, A dot B by length of B. Similarly, projection of B on vector A depends on the length of vector A dot B divided by length of A. So, this is how we are going to use to find the projection of the vector A dot B divided by length of A B or A dot B divided by length of A, depending upon the projection from A to B or from B to A on. Now, move on to the problem based on this. Now, find the angle between the vectors. Vector A is equal to I plus j minus k and B is equal to I minus j plus k. Angle between the vectors means cos theta. Vector, yes, cos theta is equal to A dot B divided by length of A into length of B. Now, what is A dot B? Just find out the dot product. A dot B is equal to dot product of I and j. 1 and 1 is 1 plus j is 1 into minus 1 plus k is minus 1 into plus 1. So, 1 minus 1 minus 1 minus 1 plus 1 gets cancelled. This is equal to minus 1. Now, length of A is equal to root of 1 square is 1 plus 1 is root 3, and similarly length of vector B is 1 square is 1 plus 1 that is also equal to root 3. Now, A dot B is equal to A dot B is minus 1 divided by root 3 into root 3, that is minus 1 divided by root 3 whole square. So, therefore, cos theta is equal to minus 1 by 3 or theta is equal to cos inverse of minus 1 by 3. That is it. Theta is equal to cos inverse of minus 1 by 3. Okay. Now, let us take a similar type problem. Find the angle between the vectors A and B with the magnitudes 1 and 2 respectively, and A dot B is equal to 1. So, they have already given the magnitude of A and B and also the dot product. Dot product is given and the magnitude of A and B are also given. Very simple. What is given? Given magnitude of A, length of A is equal to 1 and length of B is equal to 2 and A dot B is equal to 1. So, what is the formula? Cos theta is equal to A dot B divided by length of A into length of B. A dot B is 1 divided by length of A is equal to 1 and length of B is equal to 2. This is equal to 1 by 2. Theta is equal to cos inverse 1 by 2, which implies theta is equal to 60 degree. Sin 60 root 3 by 2 cos 60. What is cos 60? cos 60 is equal to 1 by 2. This is 60 degrees. 60 degrees is nothing but pi by 3 radians. That's it. Okay. Now move on to the next problem. So if A is equal to 5i minus j minus 3k, B is equal to I plus 3j minus 5k, show that vector A plus B and A minus B are perpendicular to each other. So for two vectors to be perpendicular to each other means their dot product must be equal to 0. So here just find out A plus B and A minus B. A plus B is equal to, add these two vectors, 5i minus j minus 3k plus I plus 3j minus 5k. So if you add, what you will get? Vector A plus B is equal to 5i plus I is 6i plus 3 minus 1 is minus plus 2j minus 5 minus 3 is minus 8k. This is A plus B. Now A minus B. Similarly, the difference A minus B is equal to, what is A? 5i minus j minus 3k minus, multiply by negative sign, minus I minus 3j minus into minus plus 5k. What is this equal to? 5i minus I is 4i, minus 3 minus j is minus 4j, plus 2 minus 3 plus 3, sorry, plus 5 minus 3 is plus 2. Now what is to prove? A plus B and A minus B are perpendicular to each other. Now just find out A plus B dot A minus B. A plus B dot A minus B. The dot product, that is, what is A plus B? 6i plus 2j minus 8k dot 4i minus 4j plus 2k. 4i minus 4j plus 2k. If the dot product is equal to 0, then they are perpendicular. 6 into 4 plus 2 into minus 4 minus 8 into 2. 6 4s are 24, 4 2s are 8, 8 2s are 16. That is 24 minus 24 is equal to 0. A dot B is equal to 0 means vector A and B are perpendicular. If A plus B dot A minus B is equal to 0 means, therefore what do you say? Vector A plus B is perpendicular to vector A minus B. This is also an important problem for a 3 marks. That's it. Okay. Now move on to the next problem. Find the angle between the vectors A and B with magnitudes root 3 and 2 and A dot B. Same as that of the previous problem. What is given? That given length of A, magnitude of A is root 3, magnitude of B is equal to 2 and A dot B is equal to root 6. Angle between the vectors is cos theta is equal to vector A dot B divided by length of A into length of B. What is A dot B? A dot B is root 6 divided by root 3 into 2. Root 6 can be written as root 3 into root 2 divided by root 3 into 2. 1 root 3 gets cancelled. Root 2 divided by 2 can also be written as root 2 into root 2. 1 root 2 gets cancelled. 1 by root 2. What is this equal to? This is equal to cos 45 degrees. So therefore, the angle between the vectors theta is equal to 45 degrees or pi by 4 radians. What is cos 45 and sin 45? 1 by root 2. That's a simple for 2 marks. You may expect this type of question also. Straight away just substitute the values. That's it. Next, find the projection. Now, projection of vector A on vector B. The projection of vector, find the projection of vector A on B. So, find the projection of the vector A on B. The projection of vector A on B is equal to, what is the formula? Vector A dot B divided by length of vector B. Now, just find out what is A dot B. A dot B is nothing but the dot product of these two. 2 into 1 plus 3 into 2 plus 2 into 1. What is this equal to? 2 plus 6 plus 2, that's equal to 10. Length of vector B. Length of vector B. So, length of vector B, 1 square is 1 plus 4 plus 1, that's equal to root 6. So, projection of A on B is 10 divided by root 6. So, projection of A on B is A dot B by length of B. Suppose if there is projection of B on A is A dot B divided by length of A for 2 marks. Now, move on to the next problem. If A is a unit vector and x minus A dot x plus A vector is equal to 8, then find x. This is also an important problem. So, what is given? Given that A is a unit vector. So vector A is equal to 1. Length of A is equal to 1. Now vector x minus A dot x plus vector A is equal to, let's simplify this. X into x is x square. Again, x into A, that is nothing but plus into plus, it is plus x dot A vector minus A dot x vector minus into plus minus A into A is equal to length of A. So these two gets cancelled. What is left over is length of x whole square minus length of A whole square is equal to 8. Since it is given length of A is equal to 1, 1 square is 1 is equal to 8. So therefore, length of vector x is equal to 8 plus 1. 8 plus 1 is 9. So therefore, the magnitude of the vector is root 9. Root 9 is nothing but positive value we are going to take. So the required value for the vector x, modulus of x vector is equal to 3. That's it. So this is also important type problem, you expect this type. So this, if you observe carefully, this is of the form a plus b into a minus b is a square minus b square. Modulus of x square minus modulus of a square is equal to 8. Substitute a is equal to 1. 8 plus 1 is 9. Square of 9 is 3. That's it. So these are few problems based on the scalar product, that is dot product of vectors. Now let us move on to the next concept, that is a vector product. So in vector products we are going to use vector a cross b. Vector a cross b is nothing but determinant I, j, k, coefficient of vector a and vector b. And in using a cross b vectors, we are going to find the unit vector along a and b as well as sine theta, sine of angle of intersection between the two vectors. Now let us take if a and b are any two vectors, if a and b are any two vectors, if a and b, these two vectors will represent the adjacent sides of a triangle, then the area of a triangle, area of triangle is equal to half into length of a cross b. Now here one problem is given. Find, this is also important for 2 marks. Find the area of a triangle whose adjacent sides are given by vector method. So first find out a cross b. What is a cross b? Determinant I, j and k. 1 minus 7 plus 7, 3 minus 2 and plus 2. Just determine the value of this determinant. This is plus, minus and plus, expansion with respect to first row. This is gone. I into minus 7 2s are 14, minus into minus plus 7 2s are 14, minus j into this row and column is deleted. 2 1s are 2, minus 7 3s are 21, plus k into this row and column is gone. Minus 2, minus into minus plus 21. So this is minus plus gets cancelled, 0i. Again 2 minus 21 is minus 19j, minus into minus plus. Again 21 minus 2 is also again plus 19k. So the length of this vector, length of a cross b is equal to square root of 19 square plus 19 square. Right. What is 19 square? 361 plus 361. Square root of 361 plus 361, that's equal to 722. So therefore the required area of the triangle ABC is equal to area of triangle half into length of a cross b, that is nothing but half times root of 722 square units. That's it. This is the area. Okay. Or if you want, you can also write like this, half into 19 times root 2. That's it. Okay. Right. Now move on to the next one. Find the area of a triangle formed by the vertices A, B and C. This is also an important problem for 3 marks. Now here just find out the area of the triangle is given by, this is triangle ABC. Area of triangle ABC is equal to half into length of vector AB cross vector AC. Just find out AB vector. Vector AB is equal to OB minus OA vector. Simplify this. OB minus OA. What are the points we have? 1, 2, 3 minus 1, 1, 1. So this is nothing but 0, 1 and 2. So therefore vector AB is equal to 0I plus J plus 2K vector. Similarly, vector AC is equal to OC minus OA vector. OC is equal to, what are the coordinates? 2, 3, 1 minus 1, 1, 1. So 2 minus 1 is 1, 3 minus 2 is 1, 1 minus 1 is 0. Therefore, the vector AC is equal to I plus 2J plus 0K. Now find out AB cross AC. Now AB vector cross product of AB and AC, determinant I, J and K. What are the values? So 0, 1, 2, 0, 1, 2, 1, 2, 0, 1, 2, 0, plus, minus and plus. I into 1 into 0, 0 minus 4 minus J into, this is gone 0 minus 2 plus K into, this is also gone 0 minus 1. So that's equal to minus 4I minus into minus plus 4J minus K. The magnitude of this, magnitude of AB cross AC vector is equal to root of 4 square is 16. So root of 4 square is 16, 2 square is 4 plus 1 square is 1, root 21. So therefore, the area of triangle ABC is equal to half into square root of 21 square units. That's it. So the required area is half into root 21 square units. Very important for 3 marks. You may also expect this type of question. Now move on to the next problem. Find the area of the parallelogram when the adjacent sides are given. So area of a parallelogram is equal to area of parallelogram whenever the adjacent sides are given is length of A cross B. That's it. So find out A cross B. This is also important problem. A cross B is determinant I, J and K. So this is 3, 1, 4, minus 1, minus 1, minus 1, minus 1 and plus 1, plus, minus and plus. So this is equal to I into 1 plus 4 minus J into, this is gone, 3 ones are 3 plus 4 plus K into, this is gone, minus 3 minus into minus plus 1. So this is 5I minus 7J minus 1K. The length of this, length of A cross B is equal to square root of 5 square 25, 7 square 49 plus 1. 49 plus 150 plus 25 is 75. So this can be written as 25 into 3, that is nothing but 5 root 3. So therefore the area of the parallelogram is 5 root 3 square units. That's it. Okay. So area of a parallelogram whenever the adjacent sides are given is length of A cross B. Suppose if the diagonals are given, half into length of A cross B. So the area of a parallelogram whenever the diagonals are given, so D1 and D2 are the diagonals, means the area of a parallelogram is half into length of D1 cross D2. Now here A and B are the diagonals. So let us represent this as, find out the cross product of these two. A and B are the diagonals. So therefore this is A cross B is 2, 1 and 4. Coefficient of ij in the vector B is 1, minus 2 and 2. Plus, minus and plus I into 1 2s are 2, minus into minus plus 2 4s are 8, minus j into 2 2s are 4, minus 4 plus k into, this is gone, minus 4 minus 1. So this is 10I minus 0j minus 5k. Now length of this, length of A cross B is equal to root of 10 square is 100, 5 square is 25, root 125. So therefore the area is equal to area of parallelogram. Parallelogram is equal to half into length of A cross B, that is root of 125 square units. That's it. This is how we are going to find the area of the parallelogram whenever the adjacent sides and diagonals are given. That's all regarding today's session. Let us meet with the different concept in the next session. Thank you. Thank you very much.